right. Well, well, welcome to the last week of class. Sure, you guys are excited. Katie's excited. That's why she has a packet already. So those of you that are at home, I don't have a packet to print out to give you because you're not here. But I sent out the results from the those two practice tests that we took last week. The way that this review is organized, we're going to go over the ones that were missed the most from Part A, which was the Thursday one first, and then we'll go over Part B afterwards. We'll do as many as we can today, and then anything that we don't finish today will spill over to tomorrow. Tomorrow I see you from 9:27 to 10 a.m. So tomorrow you have your first period final for the first 2 hours of school. You get out at 9:20. And then you're here by 9:27, and we'll have 30 minutes to finish, which should be enough. You didn't want the lollipop? So I would have thought some of you would have taken it more serious. Some of you did, but there were some people that I thought would have taken those last practice tests more seriously because they offered grade replacement. Like, it isn't so much that, look, yeah, your grade could not have dropped, but your grade definitely could have gone up. And some people took advantage of it, but some people didn't. So to make it clear, now you have one last opportunity to get your grade up, but in this case, your grade could also go down. The final exam is worth 15% of your final grade. But in addition to that, because you might look at it and say, oh, 15%, that's not going to make a difference. I've already failed. I'm also using it as grade replacement. I've done everything I can to bend over backwards to be able to give you guys a chance to pass. So if even after this, if you still can't, so like the few of you or handful of you who, when you look back at your test, some of you have zeros because you never took it and stuff like that. This final can replace every single test. So you might be in the 40s or something and say, oh, hey, I have no chance of passing. Well, you might, because think about it. If you were to get 100 on this final, not only would you get 100 on the final for 15%, you would go back and get 100 on every single test that we've taken. So, nobody's completely out of the woods. Now, the question is, how realistic is it that somebody who, has missed half the time, missed some tests before, hasn't really taken it seriously, how likely are they to get 100? I don't know. But, it's still mathematically possible. When is your final? No. There's not first period. Wednesday, Ferris. It's fourth period in the morning. Wednesday, Thursday, Friday are those early release days. You get out of school at 11:45. But you have each day you'll have a final from 7:20 to 9:25. Then you have a 15-minute break in between classes. And then you have your last final from 9:40 to 11:45, which in our case, we will be the second final of the day on Wednesday. And then no more Romero. Any questions? How you feeling today, Caden? You had a good weekend? So. Okay. So, yeah, so for the people at home, I sent you, I released the grades. I did it this morning. I released the grades for those first two practice tests, so you would have to use that to go along with. Everybody that's here has a printout, but for the people at home, you're going to probably just need to use you can print it out if you want, but you can go over the results that I just sent out. Any questions at home? Is that Jason that finally made it, or is that Jordan? I think it might be Jason. Jason, can you hear me? Okay. Yannick, did you hear everything I said? No, this is for Yannick. I want to see if Yannick is there. He hasn't said anything. And sometimes he logs in and he doesn't reply. Hey, what's up, Yannick? So remember, we want to make sure we take that final on Wednesday, because not only does it count for the final, but it also counts as grade replacement for some tests that we may have missed. Okay. Find the volume of the figure. So these are the ones that you missed the most. Okay. Find the volume of the figure before. What type of a solid is this? Triangular pyramid. And a triangular pyramid, and then not only is it a triangular pyramid, it's a, oops, that's not, well, yeah, it is what I wanted. You see, you can tell here, it's 90 degrees and 90 degrees. So that's the key. You want to have, in order to be a height, it needs to meet the base at 90 degrees. But then since we're also lucky enough to have a right triangle as the base, I can basically just use this as the base and the height of the base, and then this is the height of the pyramid. So I believe now you guys had your notes in front of you, so you don't have to memorize the formulas. But I believe if I remember correctly, the formula for this is base times height over 6. Does anybody have their notes in front of them to confirm that? It's the base times the height of the triangle times the height of the pyramid divided by 6. So assuming nobody well, the over 3 is all pyramids, but then since the triangle on the bottom has an over 2 on it, that's why what's 2 times 3? So I just made it easier for you to put a 6 on the bottom. So 2 times 8 times 9 times 2 should be 144. Find the volume of the right triangular prism. Okay. Now again, we're lucky that this is a right angle on the base. So then, in this case, it would just be the base times the height. But then now, for a prism, you just multiply that times the height of the prism, and there's no dividing. 5 times 8 is 40, times 3 is 120. And these were the ones that were missed the most. Oh, and the final will also be curved. The grades are in. So if I don't know, did anybody check the grade book over the weekend? No. Well, the grades have been replaced. Like I know of one person in here who made a pretty big jump in grades. But for anybody else, you just have to check and see if your overall grade changed and by how much. It shouldn't have gone down. It should have only gone up or stayed the same. The radius of the circle is 6 millimeters. What is the area of the shaded portion of the circle? Oh, and if I replace the grade, I put it in the notes. So it would say next to it, replaced by. What is the area of the shaded portion of the circle? Anybody remember what these are called? When it's part of the that's very good, the sector. So now, but they want what's shaded, so it's not the 70. How many degrees are there? If they want what's shaded, the 70 degree is not shaded, it's everything else. How many other degrees are there in a circle? Other than, no, not 230. Ooh. Yeah, 360 minus 70. What's 360 minus 70, Ferris? It is 290. So 290 over 360 times pi r squared. So pi, did they tell you the radius is 6 squared? These zeros cancel out. So I get 29 over 36 times 36 pi. Now the 36's cancel out, so I just end up with 29 pi. If you have questions, ask. This is the stuff from the first half of the semester that you probably forgot already. Find the length of arc. And anybody remember what type of arc it is when they only use 2 points? I know it's going back. What do you call it when they only use 2 points to name it? It's a minor arc, which means the shortest distance from D to E, which is here. So the formula we told you there is just get pi times whatever measurement they give you, which in this case is a radius. All right, and then you're gonna multiply that by the amount of degrees, and if it's a radius, you just go over 180. If it was a diameter, you would have gone over 360. The zeros cancel. Oh, but it doesn't. Oh, it doesn't even really matter because they want it as a decimal. So let's just do it as a decimal. 110 times pi times 4 equals, and then divided by 180. I'm getting 7.68. Yeah. If you need help putting in the calculator, say something. I mean, it's not easy to help somebody over the computer, but I've done it before. If you don't know how to use a calculator. No. How was your weekend, Lana? Study for finals? Good. What if the length of an 80-degree arc is 12, what is the radius of the circle? So here they want radius, so we're going to use the same formula. And it's 80 over, because it's a radius, it's 180. And then just pi times the radius. And that equals 12. So the zeros cancel. What does 8 over 18 reduce to? What's the biggest number? Yeah, I can divide them by 2. That becomes 4 over 9. So now I have 12 is equal to 4 pi r over 9. What can I do first to solve for r? You can do it in one step, but I like it's easier. Yeah, it's easier for you guys to understand if we do it in 2 steps. So times 9. So you get 108 is equal to 4 pi r, and then what's the last step to get the r by itself? Divide by 4 pi. Be careful putting it in the calculator. You might have to put the 4 pi in parentheses to get it to do it right. 108 divided by parentheses 4 pi. I'm getting 8.59. If you're getting something different, let me know. Are any of the in-person people going to stay home for their finals and just not come at all and just take it from home? All right, let me rephrase. Is anybody going to be here in person for the final? Cool beans. You raise your hand twice, Katie. You're going to what? Okay. What's up? Hi. Find the area of the sector. So we just did this one before. It's 60. This one has to be over 360. And oops, sorry, didn't mean to do that. Times pi 14 squared. I know this gives me 1 over 6. 14 squared is 196. So I end up with 196 pi over 6. Oh, that can also be reduced. I don't think it can be divided. No, but it can be reduced by 2. 196 divided by 2 is 98. So I end up with 98 pi over 3. And that's probably square. Let me just make sure there's nothing with units. No. This one here, B. Yeah, access Miranda. You're putting a reminder to do what study? Did you have to work this weekend? Yeah. Got to make that money. Okay, find the measure of minor arc ED. So now this is arc measure. Arc length is in units of distance, like feet, inches, stuff like that. Arc measure is just degrees. And the measure of an arc is the same as its central angle. So you've got to figure out how many degrees are there. How many degrees are there in a straight line? 180. And if this is 90, yeah, that's what Miranda said. So 180 minus 46 minus 90. That gives you whatever would be left over. Yeah, I'm getting 44. Was this multiple choice? No, this you had to type in. You would have just typed in 44. Find the measure of major arc BDC. So now we're starting at B, ending at C, but if we have to go through D, it's the long way. So it's everything except for the 46. How would I find that? Remember, arcs are still measured in degrees. You measure arcs in degrees. The answer was 44 to the last one. You can check based on what I sent you back. You can check what you put versus what should have been there. Sam, you're doing way too much work, man. There's no need for all that. How many degrees are there in a circle? 360 minus the 46 that you take away. That's getting 312. And that one you would type in also. No, wait. No. 314. Sorry. Bad mental math. 314. That's it. No, because it's just arc measure. Why divide by 2? These are central angles. Not what you might be thinking about are inscribed angles. When you have inscribed angles, yeah, then you have to divide by 2. No. When you do have inscribed angles, to get to the angle is divide by 2. To get to the outside is times 2. Yeah. Look, watch. Here we go. Inscribed angles. Okay, but now they're not giving us the arc. These are just when you have 2 inscribed angles that intercept the same arc. See, they're both eating this part of the circle. What does that tell you about those inscribed angles? Yeah, they're equal to each other. So 11x minus 3 is equal to 8x plus 15 minus 8x minus 8x plus 3 plus 3. So 3x is equal to 18. X equals 6. Yay, I'm done. Nope, because they wanted the measure of AD. So now since both of those inscribed angles are equal, I can put the 6 wherever I want. Let's just put it, I guess, here. And that gives me 66 minus 3, which is 63. So what that's telling you is that this arc right here is 63 degrees. Oh, sorry, that angle is 63 degrees. So if I wanted the arc, Paris is what we were just talking about, how would I go from an inscribed angle to the arc it intercepts? Not divide. Multiply. When you're going outside, you multiply. Yeah, when you're going outside, you multiply. If you're going inside, then you divide. So 126. Find the measure of angle ABC. Okay, so ABC is right here. This is called, it's an inscribed quadrilateral because it's made all of inscribed angles. And in any inscribed quadrilateral, the opposite angles are? No, not equal. Not supplementary. Good, it's supplementary. So it's just 180 minus 94. Yeah, so it should be 86 is what I'm getting. 86. Supplementario. Oof. What do you think, Sam? You think we can finish them all today? Nah. Find the measure of angle RST. So they want to know how much this one is here. Okay. Well, RTS is intercepting 104. If you wanted to come inside, what would you do? Divide by 2. So this becomes 52. And then how many degrees are there in a triangle? In any triangle, what do all the interior angles add up to? 180. So 180 minus 67 minus 52. 61. All right. Anybody remember what those segments are called when they're inside of a circle? When the endpoints are on the circle? It starts with C and ends with chord. Yeah, those are called chords. Thanks, Caden. And when two chords intersect, the angle that they create is the average of it's intercepting two arcs. It's eating this arc and eating that arc. So you got to do the average, which is just you add them and divide by 2. Yeah, look at Ferris. I think math is Ferris's favorite subject. So 193 plus 81 divided by 2 is 137. What? Yeah, it's degrees, but for the Google Forms you don't put in, like, you don't just put the number. You made a big poop? Oh. All right, when you have, anybody remember what these are called? They're kind of like chords because they touch the circle twice, but if it goes outside also. Secant, those are called secants. So when you have two secants meeting at a common outside point, the way you find that exterior angle out there is you're going to subtract the big arc minus the small arc and divide by 2. 97 minus, instead of adding, see on the last one when they met inside, and then inside you think plus, add. When they meet on the outside, it's minus. Big minus little, divided by 2. 35 is what I'm getting also, yep. There's some where what they do is they would, oh geez. Yeah, I know. And it was, I want to say when they put the X, oh, I know what it is. It's when they're both tangents, like this. Okay, the angle's still outside, and then they'll either call this one X or they'll call this one X, and they don't tell you anything else. That's the one where I gave you the trick for it. Yeah, correct. One of them was minus 180, the other one was plus 180. If they want the big one, it's plus 180. If they want the little one, it's minus something like that. Let's see if it comes up. And maybe not. Given the equation below, what would be the number that is filled in after the 8x? So this was completing the square. So you just divide it by 2, and then you square it. 8 divided by 2 is 4. What's 4 squared? And it has to be positive. Anytime you complete a square, it can't be negative. So you knew it couldn't be those two. Should have been an easy one. A circle has a center at 3, 1 and passes through the point 6, 5. What is the equation? All right, this one's a little bit tricky. Now the center part is easy, okay? Because if the center's at 3, 1, you know that it cannot be these two because it's be x minus 3 and y minus 1. But now you got to figure out the radius, and the radius is the distance from the center to the circle. So radius is going to be square root of 3 minus 6, distance formula, plus. Anybody remember what distance formula came from? Oh, no. What was distance formula derived from? Pythagorean theorem. So this is square root of 9 plus 16, which is square root of 25, which is 5. The radius is 5. But remember, on the other side goes, we need to put r squared. So what's 5 squared? 25. So it's this one here. The radius is 5, but when you plug the radius back into the equation, it needs to be squared. Because remember, Pythagorean theorem, a squared plus b squared is equal to c squared. So you're putting write the standard equation of a circle. Okay, where's the center at? At 1, -1. How far is it from the center to any one of those points? 2. Just remember that when you plug in the radius, it has to be squared. So 2 squared is 4. So I should see then x minus 1 and then y plus 1, because you got to change the sign. D. Hang in there, Miranda. One more week of school. Are they going to make you work a lot during the break? Probably. You too? And more. Well, what do you do now with, because now aren't all the lawns dormant? So what do you do now then? No. Write the standard equation of a circle with that diameter. Okay. So when they see now both of these points are on the circle. So let's first start with the center. This might have been the hardest one on here. You just got to remember a lot. How do you find the center when they give you 2 points on the circle? If the center is the point in the middle, and how do you find it? Was there a formula that you could use to find a point in the, not distance, to find a point in the middle? Midpoint formula. So here the midpoint would be, you add the x's, 12 plus 2 over 2, comma, add the y's, 13 plus 1 over 2. So the midpoint ends up being 7, comma 7. So we want x minus 7, y minus 7. That's going to knock out those two. Now this, find the radius, and I used to just have you find the diameter and divide by 2, but then my man Ferris came up with a problem with something I like better, which is, since we found the center, now just use that center with any point. I'll just use that one there and say the radius is 7 minus 2 squared plus 7 minus 1 squared, which is 5 squared plus 6 squared. Radius is 25 plus 36, so it means the radius is the square root of 61. But that's the radius, but when I plug it in, I have to square it. So what's the square going to do to that square root? If that's the radius, when I plug it into the equation, the square, what is that square going to do to the square root? Cancel it out. So it's just that one there. This equals 61. Get in there. Got like 10 left. The endpoints of one side of a regular pentagon are 0, 5, and 3, 4. What is the perimeter of the pentagon? What does the word regular mean? It is going to be distance formula, but what does the word regular mean? No. Doesn't mean normal. What does the word regular mean when it applies to pentagons? Or, sorry, polygons, any polygon. First semester stuff. Yeah. You remember when we had this exact same problem before, though? Not too long ago? Because this is towards the end of the first half. Regular means all sides are the same. So if all sides are the same, I'm just going to figure out one side the way that Miranda told me to, which is distance formula. 0 minus 3 squared plus 5 minus 4 squared. This is negative 3 squared plus 1 squared. That's 9 plus 1, so the square root of 10. So one side is square root of 10. But all the sides are the same, and there's 5 sides, so then what would all the sides be together? What would the perimeter be? If one side is square root of 10, there's 5 sides, all sides are the same. Seriously? Here's a pentagon. If this side is square root of 10, and every single side is supposed to be the same because it's regular, yeah, it would be B. It's just times 5. There's 5 of them, it's times 5. So the key here is also knowing that with a radical, you can't multiply the number on the inside, which is 5 of them, 5 times. You look like a ninja today, Lana, with the hoodie on. Everybody at home following along? Jason, how you doing today? Good. Jordan just gave me a thumbs up. Good job, Jordan. What are the coordinates of the point on the directed line segment that partitions the segment to a ratio of 1 to 4? Yeah, this was pretty recent. So I think actually we're already into the second half stuff. Oh, what was the formula here? So if it's 1 to 4, then you would put 1 over 1 plus 4. So what's that? What's 1 plus 4? Use your fingers. 5 times, I'm gonna have to think of this. 7 minus 3 is 4. It's not the distance. Is it just? Miranda, you keep your notes. Do you have your notes on you? Because I just want to write it the same way. I'm pretty sure you just subtract the x's and subtract the y's. Huh? It'd probably be like around week 12, 13. I just want to get the formula right. Does anybody else here keep their notes? Let's see. Go formula. Yeah, it's this one. That's what it was. Okay. So it was the way I taught it to you was pick the first point, which is here, and that's where we're gonna start the race. So to start with the x's would be -7 plus, because now you start the race. Now comes that 1 over 5, and then you subtract the x's. The finish line, which is 3, minus -7, which is +7. That's gonna give you the x's. Then what's the first y? -2 plus, because you're starting the race, 1 over 5. Now subtract the y's, 3 plus 2. Thank you. 3 plus 2 is 10. 10 times 1 over 5 is 2. So -7 plus 2 is for the x's. Then this will be -2. 1/5 of 5 is +1. So this gives me -5, comma -1. Here. -5, -1. The final, yeah, yes. Okay. From here. 3 plus 7 is 10. 10 times 1 over 5 is 2. And then this 1 over here, I got it from this. So These just drop down. The final is going to be 33 problems. You have 2 hours to do it, so. A card is drawn from a standard deck of cards. Oh, here we go. Hey, we're back to probability. Yay. What is the probability of getting a heart or a diamond? Well, how many hearts are there? 13 out of 52. How many diamonds? And it's or, so it's plus 13 out of 52. Now, is there an intersection? Because if there is, you got to subtract it. Are there any heart diamonds? Any cards that have both a heart and a diamond? No. So this is just, they're mutually exclusive. 26 out of 52 is 1/2. Olivia selects marbles from a bag containing 5 red and 7 blue marbles. Which of the following events are independent? Is that what it says? Yeah. Remember, independent just means that one doesn't. It's the outcome of one does not affect the outcome of the other. Selecting 2 red marbles and 1 pick. No, anytime you do 1 pick, it is considered dependent because you're going to be holding both of them in your hand, so it can't be that one. Selecting a red marble and a blue marble. No, 1 pick. No. Not 1 pick. Selecting a red. So I'm looking for replacement. I already know where this is headed. I'm looking for replacement. Look at it. I found it. Selecting a red and a blue in 2 picks with replacement. That's going to be the answer because that means that you put it back. Once you picked one out, you put it back. That's what makes it independent. Right, Sam? You jotting all this down? Highlighting the word with replacement. This is independent. Without replacement would be dependent. What is the probability that someone who prefers horror is a sophomore? So we're looking only at horror here. Now, they don't have the tally. We're going to have to add it up. How many sophomores are there? How many sophomores are there in that column? Because it says they have to prefer horror. There's 54 sophomores in that column divided by in total. Where's my calculator? Just add them up. 111 plus 54 plus 76 plus 84. 325. So 54 divided by 325 is about 16%, 17 if you round up. Use the Venn diagram below to find a complement. What does the word complement mean? We've gone over this already enough times, and it's been lately. What does the word complement mean? Thank you, Lo. Look at Ferris. If you were here, you'd get a candy now. Good. It means not. Not A. So what's not an A? Only 6 and 8. What was that? It was like a moose or something. Was that you, Kaden? Impressive, man. In a school election, 4 students are running for president and 5 students are running for vice president. 2 of the presidential candidates are female. 3 of the vice presidential candidates are female. What is the probability that the elected president and vice president will both be male? All right. So for the president, there are 4 students, and it says that 2 of them are female. So therefore, how many are male? Seriously? 4 minus 2? So 2 out of 4 times, for vice president, it says 3 are female and 5 are running. So how many are male? 2 out of 5. And now it doesn't say, I'm assuming that you can't run for both. You can't have one per person running for both. So this is going to be 4 divided by 20, which should be point 2. Yeah, 1 is 0.2. A. Well, we might be able to finish everything in one day. A board game uses a spinner to determine the number of points a player will receive. Each section of the spinner is labeled with a whole number. The probability a player receives an even number of points is 2/3. The probability that they receive more than 10 points is 1/2. The probability that your player receives an even number and more 10 points to 1/4. So what's the probability? Yeah, so this is the key there is or. So when it's or, you're adding the two individual ones, but if there is an intersection, like we just did the one with hearts and diamonds where there was no intersection, this one there is, so you have to subtract it. What's the LCD of 3, 2, and 4? What's the smallest multiple of 3, 2, and 4? Unless you just have a calculator and you want to put this all in there. It's 12. 3 times what gives you 12? 4. So 2 times 4 is 8. 2 times what gives you 12? 6. 1 times 6 is 6. 4 times what gives you 12? 3. So 8 plus 6 minus 3 is 11 out of 12. So it's a pretty good chance that you're either going to get an even number or score more than 10 points. A researcher surveys 100 people and tasted 2 flavors of yogurt to find out their taste preference. There's a two-way table. Which of the following statements are correct interpretations of the information represented in the two-way frequency table? Select all that apply. Only 40 people liked A. No, that's not true. Because how many people in total liked A? Oh, yeah, 50. So it can't be that one. But this one seems good. 50 people liked A. Only 40 people liked B. Okay, if you liked B, how many people liked B? 75. So it can't be C, but D looks good. Only 75 people liked A and B. Well, if you liked both of them, that's the intersection. So that's not true. Only 15 people did not like A nor B. And that is true. So that was a select all that apply. So you select those 3, B, D, and F. And we've made it to the end. Yay! Okay, this is a kite, which we didn't give you the exact formula for kite, but we showed you how you can break this down into right triangles. And then I know with a right triangle, it's just base times height divided by 2. How high is this first triangle up here? How high is it? 3. How wide is it? 2. What's 6 times? Oh, crap. What's 3 times 2? 6 divided by 2 is 3. This ends up being the same there. Okay. The bigger one now is 3 high. How wide is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 9 is 27. 27 divided by 2 is, I believe, 13.5. And this is the same also, 13.5. So you can just add them all together. 6 plus 27, the answer. And this is, I think you have to type it in. It's 33. That would have been the area. Any questions for me? I won't have anything new for you to do tomorrow. If you want to go over any of these practice tests, if you want to go over maybe that last probability test that I sent you and see if you have any questions on it, I can help you guys individually. So, any questions from anybody at home? Yeah. $13.5. It's base times height over 2. It's base times height over 2. So, like this is 3 high. It's 9 wide. So 3 times 9 is 27. Divided by 2 is 13.5. And both of these are the same. They're both the same dimensions. So they're both 13.5. And then just add them all together. 3 plus 3 plus 2.